Hello and welcome. Today is 1st December 2020 and we are learning number systems. Specifically today we are going to find out how do we solve problems of finding out a set of rational numbers between given two rational numbers. Well, there are many ways to go about solving questions like these. Specifically, we can use any of these three techniques. The first one is known as the average technique. Second one is we convert the number to decimal form and then convert them back to rational numbers. And the last one is expressing rational numbers in equivalent forms. These are some of the three methods we can use to solve questions like these. Now let's find out what these methods are and more importantly, how and when to use these methods. So let's take a look at the first one, which is the average technique. Well, average technique is really what it says. We find out average of two numbers. So let's say we have a number A and we have a number B. So how do we find out average of two numbers and what does that really mean? So if this is A and this is B, average of A and B will give us the midpoint here between A and B. So this will be equidistant, right? And how do we find out the point C? Well, point C will be simply the sum of A and B, and we divide that sum by 2. That will give us the point C. So if we are given, say, two whole numbers, say number 2 and number 6, and we are asked to find out five rational numbers between them, we should use something like an average technique. When we are given whole numbers and the number of rational numbers we have to find is relatively small. So let's use this and see how we can solve it. So what is the average of 2 and 6? So we can visually try to see it like this. So if this is number 2 and this is number 6, so the average of 2 and 6 will be 2 plus 6 by 2, or simply 8 by 2, or this will be 4, right? So the midpoint here is 4. And now we know the midpoint of 2 and 4 is 3. Again, using the average technique, 2 plus 4 by 2. And average of 4 and 6 is 5. So now we have found three numbers. Let's write the numbers here. So first we found out 4, then we found out 3, then we found out the number 5 itself. So these are three rational numbers. We have to find two more. To find the remaining two, we can find out the average of these two, or these two, or these two, or these two. So any of these will give us average of the numbers, and we need to find out the remaining. We can find out remaining two numbers. So this is average technique. Let's move on to the next method, which is converting from rational number to decimal form and convert them back. What do we mean by this? So let's say we have two rational numbers, and let's write whole numbers again, the number 1 and number, let's say, 2. We have these two whole numbers, but we have been asked to find out 8 rational numbers between them. Now, if we use average technique, we have to find out a lot of averages. Because the number of rational numbers we have to find out is high, it will take too much time. So there is an easier method. Let's find out what this method is. So what this method is telling us is, let us write each of the two numbers given in decimal form. So we can write 1 as 1.0 and we can write 2 as 2.0. So you may be wondering, what good does it do? Well, if we write 1 as 1.0 and 2 as 2.0, now we can very easily find out rational numbers between them. Because now we know that the rational numbers, let's write it here, 1.1, 1.2, 1.3, 1.3, 1.4, 1.5, 1.6, 1.7 and 1.8. All these numbers, they lie between 1.0 and 2.0 and hence between these two numbers. And now comes the part of converting them back to rational numbers. We can easily convert each of these numbers back to rational number form, in the sense we can write 1.1 as 11 by 10. We can write this as 12 by 10. We can write this as 13 over 10, 14 over 10, 15 over 10, 16 divided by 10, 17 divided by 10, 18 divided by 10. So we have found out all these numbers. These are rational numbers between 1 and 2. So this is my favorite way to find out rational numbers, specifically when I have a large number of rational numbers to find. Let's take a look at one modified form of this example. So let's say our numbers are still 1 and 2. They are the two numbers. But instead of finding out 8 rational numbers, we have to find out now 12 rational numbers. And I have increased the number on purpose because we can write 1 as 1.0 and we can write 2 as 2.0. But if we do it this way, we can basically find out the number 1.1 through 1.9. And this will give us 9 rational numbers between these two. But we need 12. So instead of writing it as 1.0, what we want to do, we want to write it as 1.00 and we want to write this as 2.00 because these all are the same numbers, right? They're all the same numbers. So the advantage that we have here is now we can find out easily 12 rational numbers between these two because we can write them as 1.01, 1.02, 1.03, so on and so forth, 1.10, 1.11, 1.12. And now we can, so this is the decimal form and we can then convert them back. 101, we divide that by 100 because there are two decimal places. 102 by 100, 103 by 100, and so on and so forth. So this will be very similar here. And we have very easily now found out 12 rational numbers between the number 1 and 2. So this is what the second method is, where we convert our given numbers to decimal form and then we convert them back to rational form. Alright, let's now move on to our last method of converting the given numbers in equivalent forms. So what is this method and when we should use it? If our given numbers are in the form of fractions, so let's say 2 by 3 and let's say maybe 6 over 7. So these are two rational numbers and we are asked to find out 7 rational numbers between these two. So this is when we use this final technique, and the way we do that here is we convert each of these numbers in an equivalent form. And we know how to do that. We are going to make the denominator same. So we can write 2 over 3. We can multiply the denominator by 7, the numerator by 7. So this will give us 14 by 21. So 2 by 3 is the same as 14 by 21. Similarly, 6 over 7, we can write this as we can multiply both numerator and denominator by 3. So this will be 6 times 3 over 7 times 3, or simply 18 over 21. So our question has become from 2 over 3 and 6 over 7, it has become 14 over 21 and 18 over 21. So at this point, we can easily find out some rational numbers between these two, but can we find 7 rational numbers? Let's see. So between 14 and 18, we have 15 over 21, we have 16 over 21, we have 17 over 21. So we have found 3 numbers between these two, but we have to find out 4 more numbers. So one thing that we can do is we can write them in equivalent form still. What do I mean by that? What we do is we simply multiply the numerator denominator by a larger number. And my favorite larger number to go to is 10. Because if we do it this way, so 14 by 21, we can write this as 140 over 210. And 18 by 21, we can write this, multiply both by 10. This becomes 180 by 210. Now we can easily find out our numbers between these two. So we can write this as 141 by 210, 142 by 210, 143 by 210, 144 by 210, 145 by 210, 146 over 210, and 147 over 210. So here we have found out 7 rational numbers between these two. So if our starting two numbers are in fraction form, in a rational number form, we absolutely want to use this third method. Again, keep in mind that all of the 3 methods we have discussed today, they all will be able to give us the infinite rational numbers that exist between n two given rational numbers, but we want to use these techniques in these specific cases to be able to very quickly, efficiently answer these questions in a timely fashion.